All right, welcome team. Another session for GenAI Engineering. So today we will be talking about a no-code platform, UI-based, called LangFlow, which is part of the DataStax company. Was part of DataStax company. Now DataStax is acquired by IBM a few months, like in about 6 months ago or so. Now it's part of IBM. So every big company is trying to have their own footprint in the AI platforms, right? So as part of that, IBM acquired DataStax. So DataStax has two products. One is AstraDB, which is a vector database. Again, as we know in the RAG, we have explored few vector databases, right? Few vector databases we explored, FireDB, we explored ChromaDB, we explored Pinecone. So similarly, we have one more vector database called AstraDB that we will explore today with RAG architecture. Okay, and this platform is called LangFlow. Okay, so LangFlow is basically you can do all of this, but in a visual editor. So it's more like you have seen older ETLs. You used to write SQLs for ETL and Python scripts or whatever scripts and transformations. Later, you had different products that came in where you can drag and drop and then connect the input and output to the following steps, right? Sequence, like you had Pentaho for ETL, you had Informatica, which was very popular, and few other ETL tools, right? So where you have a menu on the left, and then you have the components for each action. So you want to filter, you want to join, you want to connect to database to pull the data. You can visualize the data. You can transform the data. You can write transformations on each field. Let's say if it is a date time field, you truncate just to date, or when you join two data sets to become one data set, you can do inner outer joins, you can specify everything you can do visually. UI, drag and drop and choose and select. There might be a little bit coding where you want to actually write that transformation in a different language for each of those, but it's mostly like low code or no code platforms. So similarly, we have here what we call we have LangFlow, and we have also other platforms also, like all the hyperscalers. We have Amazon Bedrock, we have Google Colab, sorry, not Google Colab, so GCP, Google Vertex AI, basically. Vertex AI Studio and Amazon Bedrock, and we have AutoGen, and then we have Microsoft Studio, AI Foundry. All of these are like your platforms to build RAG and build agentic AI on visually through UI without, we have been doing for last 3 weeks, 6 sessions. We are exploring Google Colab, writing Python code to explore all of this. Now we'll take the same use case of, the taking a document, splitting it into chunks, using an embedding model, create embeddings, write it to a vector database, create a prompt, use a large language model, any OpenAI model, and then test it, ask questions from the document. But we will do everything on the UI. We will not use Google Colab today. Okay, so that's what we are heading. So we all know, so I said, right, the first 4 weeks, we are going to build this to pulp every single session and, be very confident about this architecture. Okay. This again, as I was talking, the SLMs or domain specific LLMs, most training happens using the RAG architecture because they have to be trained on your personal company's personal data kind of a thing. So what is LangFlow? I have very few slides, just one or two slides, then we will get on to the directly hands-on the platform. So it's an open source platform that provides a visual drag and drop interface for designing and building workflows with large language models. It's built on LangChain, of course. So we have this libraries, right? LangChain libraries. So it under the hood, it uses the LangChain library to give you that interface, but to create those components. Exposing powerful components like chains, agents, and tools as easy to use visual nodes that you can connect together. So it's kind of each one is a node, visual node, and you can connect each other. So it's a drag and drop UI. You don't need to write complex code. Simply drag components onto your canvas and connect them visually to create sophisticated AI workflows. No need to write complex code simply, but if you choose to customize or add any of the code which is not supported, that still is possible. You can also go back and edit and write the code behind those components. So this is helpful for rapid prototyping because so end to end you can create the entire RAG architecture very quickly, less than 30 minutes. You can create the RAG architecture and do a testing prototype. Okay, all you need to do is just drag and drop, connect, click, and then boom, you have your RAG pipeline. Okay. So this we so what are available on this platform? So basically, just like any hyperscalers, we were actually looking at multiple. We looked at in the first couple of sessions, right? First session one, session two, we looked at different platforms and what LLMs they provide, like hosted, right? So when we went to Google, we saw there are a lot of Google models, but then there are also some models from Cohere, some models from Anthropic that you can select and use it on the Google platform or Microsoft or Azure or on the Bedrock platforms. We looked at Bedrock. You can use Titan or you can use any hosted other vendors LLMs. So same thing on the LangFlow platform. Again, you can use any of the LLM providers, OpenAI, Azure OpenAI, Cohere, Llama, GPT, Hugging Face, any of those models that you want to, you can, whatever are available hosted, you can use. You can also bring in your own LLMs. You can connect to any of the vector stores, like I said, Files, Chroma, VV8, Pinecone, Milvus. However, the natively integrated, because they have their own vector database platform, is your Astra DB. Okay, so we'll start with Astra DB today, and then we'll connect to the this thing. So Astra DB also one of the vector store that it has natively integrated. You can directly connect. Rather, from the LangFlow itself, you can, when you are creating your RAG, you can just create your database and your collection directly from the LangFlow itself onto the Astra DB as they are natively connected. You just need to have the key to connect and create. So data sources, again, on the left, you can create, you can add files, you can connect to SQL, NoSQL, any of the sources, to pull the data into your RAG architecture. You can connect a lot of source databases, a lot of sources that you can connect to. You can add your custom code like Python scripts and shell commands as well onto the LangFlow. So that's it. So let's get hands-on. Any questions before we move forward? No, I think once you look at this, you will know. Once you look at the platform, you will have more clarity. So let me get here. And let's see where we are. Okay, we'll start with AstroDB here. Let me start sharing again.
Hey, Harun, is AstraDB open source or a paid license?
It is not open source. It is with IBM under the IBM company, but they it's like any other product. You have a trial version or a limited version where you can create your account and do some hands-on. But for commercial purposes, for the organizations, they will have an enterprise version as well. Okay, this is a like community edition or whatever you can use. So if you go to Astra DB, so this is a from still says data stacks. Okay, if you go here, see here, if you say data stacks is an IBM company. Okay, so it was originally data stacks, but then it's acquired by IBM. Now you can see here, try Astra DB for free. You can go and then just sign up with Google, use your Gmail ID, and then you can sign up. You will automatically get access to both LangFlow and Astra DB. As I said, they are native, both from the same company. So you can just register and then you get access to all of these LangFlow and Astra DB kind of thing. That's it. Okay. Now, it's as simple as that. Once you create the account, you go to AstraDB, login. You will also, from here, you can navigate to, so you can navigate to LangFlow directly from here. There is another thing called streaming. Will not go there right now. AstraDB, LangFlow, you can see there is billing, there is integrations. For commercial purposes, you don't need to worry about it. They don't ask credit card when you're creating the account, so that should be fine. Now, first thing, you can go and say create a database. Okay, so I have a database here called Resume DB, and within that, if I go to Data Explorer, I have a collection called Resume. So basically, again, you can look at it as database and schema, or schema and tables here. This is the database, or you call it database, and then within the database you directly have a collection where your records are stored, just like we talked about, right? In other databases, the pine cone and other things, you have a database and then you have a collection. Again, when you are creating a database, you have all of these. You can select what cloud, underlying cloud, where you want to install this, because it's all cloud based, right? So you have an option, again, the 3 hyperscalers, you can choose where you want to create, and under that you can create a collection. When you create a collection, what do you need basically to store vector database? Why is this? No, don't give up. Why did it go to LangFlow? Okay. All right. So what do you need to store? What do you need to provide to store your data in a vector database? What are the 2 components? What do you actually store in the vector database for any data?
Dimensions, right? The data on the dimensions.
No, there is no answers in the data, in the vector database. What do you store in the vector database?
PDFs, source files,
Yeah, source files you will store, you break it into chunks, but before you
chunks. Yeah.
Yeah, before you put into vector database, what do you do with that data?
We do embedding.
Embedding
Right.
engine.
So you create embeddings, right? So
Yeah.
embeddings, when you create embeddings, right, Nitin, you create embeddings. For embeddings, you need to know the dimensions, correct? How do you get the dimensions? Who will decide that dimension? What decides that dimensions? 1500, 3000, or 5000, that vector size? Or what do you need to generate embeddings? Who generates the embeddings?
That's the embedding model.
Correct. So you need to have an embedding model and you need to have a dimensions,
Yeah.
right? So if you go here, right? So if you go here, you see here, you have the sources, but you need to generate embeddings. For that, you need a embedding model, and the embedding model will tell you what is your dimensions that you need to store in the vector database, and then you should use the same embedding model to query the database for relevant context results to get the response out. Okay, so if you come back here, let's say I start create new database. I will just give cohort 5 as a database name. I'm choosing AWS, US East 2 region to create this database on, and then just say create database. Okay, that's it. It's pending. It will take some time to get created. And then we can start creating the collections inside it. Okay. Now, by the time before we do that, we have, so here, environment variables you can set to connect to the database directly, Astra DB application token and API endpoint. Since it is already integrated with LangFlow, you don't need to provide an API endpoint. It will automatically find the endpoint, but you need to create the token. Okay, so how do you create token? You just go here and create a token. This is for this database. Anywhere you want to connect to this database, you need endpoint and token. So endpoint is already, so this is generating here. It's still not up. So once this is created, then you will get your endpoint. So it's initializing. Once it is active, you will get the endpoint here, and you can generate the token here. So these are the two things you need to connect. From LangFlow, endpoint is optional. You don't need. You can just connect using application token because they are natively already integrated. So it knows the endpoint. Now, token description, I will just say cohort 5 token, never expire, and then say generate a token. Okay, so you get this token. You can look at it, but say this is the token, just copy it and somewhere here, let's go and put it here, save it. This is for the cohort 5. Astra DB database. Okay, so we have the key now. Now, endpoint, okay, it's still going on. We don't need the endpoint right now, but let's see. So I want to give you a heads up that this Astra DB and LangFlow is still very early stages, like it's say still in preview. So there are some issues, like sometimes it doesn't respond, sometimes it doesn't even open. So till yesterday, my old account, I was not able to bring it back. It doesn't load. So I had to create a new one. And do it all over again. So just a word of caution. So don't get frustrated. I mean, anyways, you're not paying for it. It's free, so you cannot complain. It is like, kind of still in preview. but that's fine. So see, now you have the endpoint. If you need, you can use this endpoint as well. Let me just write down that as well. Point. Okay, now this is created, cohort 5. It's still initializing the database, but that's all you need. So if you want to connect, okay, you can connect from client, or there is a Python code. So remember from Google Colab, if you still want to connect from Google Colab to this Astra DB, forget about LangFlow. Just like you are connecting to Chroma or you're connecting to Pinecone databases, you just need to copy this code onto your Python code, wherever Visual Code or Google Colab, and then replace your token and endpoint and the key space. When you create the key space, these three, it will automatically connect to the database. Got it? Okay. Any questions?
So to deploy Astra DB, you have used AWS instance.
Hmm.
So along with Astra DB, so we need to also have AWS account, right?
No, you don't need to. I didn't have, right? So that is underlying. It's the way, it's where your database sits on top of. They will automatically take care of their underlying platforms. It's just you can choose more. Even if you want to deploy Databricks or you want to deploy Snowflake, all of them give you an option of which hyperscaler you want to go with. It's, you're not directly interacting with them. It's just a choice, because it has different regions for data security and all of that. So based on what you choose as underlying platform, the Astra DB has to manage those regions and cross-region visibility and all of that if you want to implement security on top of that. But for simplicity, you don't directly interact with your AWS unless you want to have your own account and then deploy it on your account, kind of a thing. But here, it's a choice. It's their own cloud. They have a choice to deploy their product on any of the cloud, but they will take care of all the security and everything, the processing, the underlying VMs to run your queries and all of that, they will manage. You are not directly interacting with that. But then you can you talk to the Astra DB, and the Astra DB sits on top of AWS or Azure or whatever to manage that.
Yep. Thank you.
Okay. Yeah. All right. So we have created the database. Now the next part is to create a collection. So there is a key space also. You can think of key space as the schema, but I'm using, so let's say, default schema. This is the database. This is the schema, a container for one or more collections or tables within a database, which is your schema, right? So this is the database. This is the schema. Now this is like a table or collection. So we go here, create collection. We give, say, let's say resume is the collection, vector enabled. Generation method, you can say I want to bring my own embeddings. So I want to use OpenAI embedding model and then generate embeddings and give you that to store. Or it gives an option to choose their own, like NVIDIA embedding provider integration. So you don't have to generate any embeddings. You just give the chunk. It will automatically generate the embedding and store it in the vector database. That's what I said. Some vector databases have their hosted default embedding models that you can use. Or you can say bring my own, in which case you need to provide the dimension. What dimension you want to provide when you are creating the collection. See here example, If you are using ADA 002, it's 1536. If you are using any of this, 1024, depends on which model you want to use. So you have to give that dimensions here. So it does not ask for what model specifically because it doesn't care. All it cares about is only the dimension. You can use any models as long as you can produce an embedding with this dimension. That is the only thing it cares about, dimensions. Similarity metric, you can use any of this. We talked about this to do the similarity search within the vector database that compares vector direction, magnitude, dot product, Euclidean, cosine. It supports all three strategies, approaches to search. That's it. All you need to do is your collection name, dimensions, cosine, and say create collection. So it goes and it creates collection. You are done here. You can look at the data. So if you go to my earlier resume DB, go to Data Explorer, same thing. We have a create collection created, and then update 36. We have already. Yeah, see here already 42 records from in the resume DB. I don't know why it's not showing the records here. It should show. Yeah. So these are the records yesterday I worked with earlier, and this is how it's stored. This is a vector 1536. This is the ID, and this is the actual content, the text. Okay, and this is the metadata where we put it from. You see Harun Rashid Syed resume latest.pdf file. Okay, so that's creating the database, creating the collection. Now we have almost kind of the new resume, new database, which is our cohort 5. We have our collection, which is resume. So this is the database, cohort 5. Default key space is schema. Resume is my collection where I can put all the resumes here. 1536 dimensions, cosine similarity. I don't know why it's showing 42 here. It should not be, right? It's a different database, different collection. Okay, anyways, so that's how you create a collection, right? Now let's go to our LangFlow. Okay, you can just switch from here as well.
Arun, I have two questions.
Yeah.
Yeah, one thing, maybe we covered this thing earlier, but let's say resume, right? When you upload it and the data is there and then it creates the embedding and put it into the vector DB, those values. So understand that for each word or each token of that document, it will create a dimension, right? The dimension value for it, and then put it in the proximity depending upon, like if you're using cosine, then it will use cosine proximity to put each word in proximity to each other, right? Is that what it is doing, or like it's not that the whole
It is.
resume has one
Actually,
dimension.
it's not the token. It is the entire chunk. Okay.
So each chunk, okay.
Yeah. So your embedding represents the entire chunk. Now your chunk can be just one word. It can be one sentence. It can be one paragraph. It can be one entire page. Remember, we looked at embedding models limitations.
Yeah.
10,000 characters or 5,000 characters is what tokens, 5,000 or 10,000 tokens, it can um, generate an embedding for. It can process at one time and generate embedding for. So up to that limitation, you can choose any number of tokens. Like if I want to, say for example, I'm embedding customer records. So each customer record will be one chunk. So customer record, you might have name, address, phone, email, whatever. So that will be like completely one line or maybe 3 or 4 lines. So that is completely one embedding. Now, when you're searching for customers, anything that is related to customer, it will hit that chunk and then it will give that record back. So your embeddings is not for each token, your embedding is for the chunk. But the
Okay.
chunk size can be varied. It can be one token, it can be one token, 10 tokens, 100,000, 5,000, as much the capability of the model to generate the embeddings. That's the
Okay.
limitation.
Okay. Now let's assume a scenario where, let's say, this customer data, right? If it
Mhm.
goes beyond that limitation, like 10,000, right? Then you are chunking into two, right? Um, in that case, when I'm doing a search, how will it know which two dimensions? I mean, it will create two dimensions for that customer, right? How will
Yes.
it know which which of the two? I mean, are they in near proximity, those two
You tell me,
vectors?
when you're doing a chunking strategy, there are two parameters. One is the chunk size, and there is another parameter.
The overlap, right?
Exactly. So what you do is you take an overlap from the previous chunk, right? So let's say your total uh, customer record is 150 tokens, and you are chunking at 100 tokens. So what you will do, your first token will be 100 for 100, first chunk will be 100 tokens. The second chunk, you put around 30 tokens as overlap. So the 30 tokens from the first chunk plus the remaining 50, the 80 tokens will be part of the second chunk. So there is some common information between these two chunks. So when their embeddings are created, they will have some closer proximity because there is a common information that we are repeating in these two. So based on that, they are closely related. So when you search, highly likely that in the return, when you want to return three matching records, the two
I got
records
it.
will be from this.
Got it. Got it. Yeah, that explains. That explains. And my other question is about this the vector size, right? 512,000 something. Is
Mhm.
there any indication about which one we should choose, or does it come by experience, or is it like a
Yeah, it's
iterative
more
process?
trial and error because
Okay.
it depends on your use case. You want more complex, or my use case is simple.
Got it.
So, and scalability. Do I have heavier machine, strong vector database that I can process? Go for bigger one. If I have smaller, I just want, again, not very huge use case. I just want to go with um, Chroma DB or smaller ones, use the smaller dimensions.
Uh-huh.
Because the
Okay.
more the dimensions, the more complex the embedding is. The vector search will take time to do, and the results will also be varied,
Mhm.
more focused. But if it is less embeddings, the search results are not as accurate as. See, basically, if you fine tuning, right? If you have 1,000 variables to segregate with compared to say 100 variables, so you get a lot of similar information when you use 100, but if you use 1,000, you get more fine-tuned search results, very close. So the quality will be more when you use more dimensions. But again, the trade-off is your size, your model that you have to pay for, and then the scalability that when you search, it will take time, more time to get the results, that lag you have to um, account for, and then processing time and money that you have to look for. scalability.
Understood. Great. Thank you.
Okay, awesome. So let's get back. Good questions, Neeraj. I think everybody will benefit. Others, if you have any questions, feel free to ask, and I'm giving you the little breaks, right? So, or at the end of the session. Now, so we go here, LangFlow, and we go to my projects. Okay, what it looks like. So it say here data stacks LangFlow is in public preview. It's still in preview, not commercial or GA available, I think. So we go here and we say new flow. Okay, so this is your flow where you can do templates. You can create a basic prompt template. You can create a RAG, or you can create agents. Okay, so these are the templates that are immediately available. Now, if you check, say, basic prompting, so this will automatically give you this. What is basic prompting? Is just a chatbot. You are asking a question to your LLM, and the LLM is answering you. Okay. So what you have here, chat input, basically where you can go and input your question. That will automatically send as a prompt. Prompt template, if you want, you can template with prompt template with dynamic variables. Okay, so if you go here, so this is your prompt. Answer the user as if you are GenAI expert, enthusiastic about helping them get started building something fresh. Okay, I can say generate, let's say, about topic. Okay, so I put it in the braces. That's my variable. And then I saved it. So here the input and both are coming. Input is, see here, how you gonna connect, right? In the code, we have written lang chain, input dot create chain, LLM dot execute, and all of that. So here it's going to use these connectors. Basically, you can drag and drop and connect, this input. Okay, so you just go put it here. That's it. If it is compatible, it will connect. Okay, if it is not compatible, it's not going to connect. So it cannot connect here. That says automatically that that's not where it goes. This is where you can receive the input. Now this is the system message that is coming from your prompt. Okay, now you need a model to answer, right? So you can select your models and your key goes here. So where is this key coming from? Remember, in our code we had in our Google Colab, we were saving this keys here, right? Open API key and the key name for our Pinecone. We have a Pinecone key we were storing. The same thing here. You have a very global variables. You can go and add your variable here, whatever variable name, and then choose which field it wants to apply to that variable. So what I did, I created an OpenAI API variable and gave that key here. Now, the moment I gave, it can go and connect to the OpenAI API. And there are some models. You can choose any of the models from OpenAI because it's all same key is used, API key. You can choose any model you want to get the answer from. Now, then once you get the answer, you are connecting to the chat output. There are two things. Goes to playground and publish. So we'll just click this and then we'll come back and talk about. So what I will do here, I will just say, okay, I'm just saying cricket. So what to do with cricket? We'll see what it does. Does it tell me about cricket? Does it ask questions about cricket or what it wants to do? I think so long. Let me see what's happening here. Okay. And let me. So topic here, I'm giving cricket. It's looking for an input. So I'll just go here. This. I'll just remove the variables and see. Check that later. Save. Just take the prompt. Pending rollback header. Okay. Okay. So that's it. This is like your chat bot. Okay? Now you can chat with your LLM. It's like just think of it as just like your chat GPT. Okay, this is your complete chatbot application. Within like 5 minutes, you can create this application. Now it is connected to this GPT-4o mini. You can ask any questions. It's going to answer from its LLM. Okay, and then say I want to ask how is the weather in Dallas today. Is it my laptop that is slow, or is it just the network or the LLM? I don't know. Let's wait. Yeah. So what is the difference between ChatGPT and our application? I can't provide real-time weather updates. So as we know, this is the limitation of the LLMs. They don't have the current information about anything. But ChatGPT can get you because it is already connected to the tools that can connect to internet and get the information. That is what you also need to add to your application if you want it to be a complete chatbot with general knowledge. Or if it's just only your internal RAG, then you don't need the general knowledge, current affairs. You just need to ask questions about your own company, so you don't need to connect to the tools. But this is the basic chatbot you can build with visual IDE, visualization, in just 5 minutes. Now I can go switch my model, okay, for 3.5 turbo, 4 turbo, whatever I want. Just change the model. That's it. Don't need to do anything. If you go and say, ask the same question. Class. So everything same, application, chatbot, but this time, what is the model that it is using? Okay, now it's switched. The model is GPT-4 Turbo. That's what we are using. Correct? So that's your basic model. Now you can ask me how I can go and see, look at tools and all of that. So each thing here is basically a widget. If you see, there are some controls here. You can check on controls, you can check on code. So if you go to code, you can see the underlying LangChain code that what you were writing earlier, the template that is generated. Okay. So if you want, you can edit your Python code here. If you want to add your own custom code, anything, you can do it here. But general, so it says OpenAI model. See the min max tokens range for this input is this 128,000 tokens. It can take input in the context window. The maximum number of tokens to generate. Sorry, I think this is the max. So this is the max tokens display name. So for max tokens, this is the minimum, this is the maximum. So you have all of those drop down OpenAI model names, all the model names you have, default to this openai.com, OpenAI API key. You can set your temperature, seed, max retries, timeout, all of these in this here. Okay. Now, if you go to controls, you can do this again here also. You can set all of this. You can set your temperature, you can set your keys, model names, whatever. If you want to show what you want to show, what you don't want to show, you can set the controls here. Later, I will also look at how you can add tools to it, but we have not looked at the tools right now, so we'll keep it reserved for the second half of our training when we go agentic, starting next week. So this is the basic chatbot, basic prompting. Are you guys clear how to build a basic chat prompt?
Yeah.
Okay, great. Now, if you look at before we go build the RAG, we'll look at the components here. So we say inputs is a text input. So let's say if I don't have a template, if I want to just start building it on my own, all I have to do is input, drag and drop. So that is your.
Harun, sorry, somehow I missed it. Can you come again from the starting? So where you open this long flow, or can you summarize exactly in 1 minute or something from where you start?
Yeah, we will do. We'll start another new one. So we will start a RAG. So we'll get there. Basically, yeah, you can just log in here, AstraDB, or just when you log in, you will go to AstraDB. Here, you will have if you go applications, you will have LangFlow. You just click on LangFlow, it will take you to the LangFlow projects. And then you can say click on new flow, you will get to the new flow. Then you can choose any of these prompts, any of the templates, sorry, not prompts. So I chose basic prompting template, and we will now go to the RAG. So before going there, I want to show you what is all available here. inputs, text input, chat input. It's disabled because chat input is already there. You can only have one chat input in one flow. So if it is not there, you can input it, drag and drop the chat input. Output, again, same. You can have a chat output, text output. Prompts is this one. You can have a template where you can provide variables, send variables, connect it, and send variables to this prompt from different inputs that you can send. As you have been doing in the prompt template, you can add the variables here. Once you do that, now you come data sources, right? So sources can be your file, your directory, your S3 bucket from AWS S3, SQL query, URL, webhook, any of this. Okay. So if we put SQL query, which is in beta, it's like you want to connect to any database, your RDBMS or your customer information that you have. You can go and do this, give database URL, columns, pass through, and then your query here. It will go run the query and get the information and then pass it on to the RAG or the flow here. Similarly, you can get data from directory, file, or whatever. So we are going to see the same thing, how we will upload our file, our resume, to build the RAG application and then connect it to the inputs. So these are various inputs that you can do. And processing. So once you have, let's say you are getting two different sources, just like any ETL, you can do combine data, combine text, convert data to a data frame operations you can add, you can filter, you can lambda, you can do routing. So parser, you can save to file, split text we will use for our chunking, update data. So all of these transformations or actions are possible to configure in the flow pipeline. Then comes our major brain is the LLM models.
One quick question. So I mean, I'm sensing it that you could add multiple data sources, right? Not just one.
Yes, you can add. That's why we have here combined data from two sources. You can join, combine both, combine text and filter and do all of that. Yes, you can have multiple sources. So models, again, as I said, you can select from Bedrock, from Anthropic, from Azure OpenAI, Cohere, DeepSeek, Google, Grok, Hugging Face, Mistral, NVIDIA, just OpenAI, Olama, Perplexity, Samba Nova, Vertex, Google Vertex AI, so XAI, all of this you can add as your LLMs. So for example, if I go and put Cohere, okay, so it needs a Cohere API key, and then once you have that key, it will give you which model that you want to choose from that Cohere API key. So same thing, basically, we are using here the OpenAI a key here. So once we have this OpenAPI key, so it will give us the models that are available on the OpenAI to select. That's what we are selecting. So this is the LLM models that you can select. Now vector stores, as I said, right? Vector databases. This is the AstraDB, which is native. You can drag and drop AstraDB. Same thing again, you can see you can use any of the vector databases, Cassandra, ChromaDB. We work with ChromaDB, ClickHouse, Couchbase, Elasticsearch, FizeDB. We worked with FizeDB as well. Hyperconverged, LocalDB, Milvus, MongoDB, OpenSearch, pgvector, Pinecone. Pinecone also we worked with. So we worked with Pinecone, we worked with FizeDB, we worked with ChromaDB. Now we are exploring the AstraDB. Okay, for vector databases. So you can choose any of these vector, Weaviate, any of those. Here is your embedding models. Which model you want to use to generate the embeddings? Again, there are different options from all of these providers. You want to go embedding models from Bedrock, you want to go embedding models from Azure, Cohere, or embedding models from any of the OpenAI, Mistral, whatever they are providing. You can choose one of the embedding models. So there's a difference. This is embedding models and this is your LLM models. We know in RAG we use both, right? So here, come back. So here we use embedding models and here we use language models. So these are two different sets, what is available in each. Okay. So that you select your embeddings. Now these things we will come back when we building the agentic AI, where you can add agent, you can add memory to the agent, you can add tools. This is the most important part. This is what enables you to, let's say we have a tool, Google search or DuckDuckGo search or Tavili search, SERP search. Any of this if you add, it will have automatically the capability to go to the internet, search and get the latest information when the LLM is not able to provide an answer based on its own knowledge, like the question we asked about current today's weather. So when you add one of these tools to your model, LLM or your RAG, so then it will automatically use those tools to go and get the information from those sources. It can be can be a calculator to do calculations. So we'll talk about it later. I mean, we are jumping the gun here. I'm just showing you. And then you also have bundles for integrating all of this. LangWatch we will do separately. Crew AI we will do separately in the second half of our training. But all of these are available to integrate. Out there, I think the best UI based, visual based platform, I think I have seen this as the best one, but this is still in preview, not very stable. I started looking at it, from very early, but it was very unstable. But I think now it's in a good shape, at least. Okay. So these are all the components that are available to build your flow. Okay. Any questions on this? Of course, we will not explore each and everything, but I will show you some of them, how to build a basic template. Are we good? Can we move forward?
Yep.
All right. Awesome. Let's go here. I have both. So I should go to the. So let's go to AstraDB here. We'll leave it here. Okay. We come back. Now go to my projects. I will go create. Now I will select this template for vector store. Okay. So you don't have to do anything. Your complete RAG is available here. I will go and rename it to cohort 5 RAG. Saved. See, there are two parts to it. Can you see? This is the top part and the bottom part, right?
Yeah.
So what do you think the top one, bottom? Why do we have two? These two are not connected in the RAG. In the RAG flow, everything should be connected, right? What do you think?
I think one is data engineering pipeline and one is for.
Okay. Yeah, you're right. So you're close. Basically, yes, the bottom one here is your data preparation, your data pipeline. The top one here is your query pipeline, so RAG. So if you see here, the left-hand side, this one is your data prep, right? The source. You take the source, chunk it, embed it, and write to vector database. This is preparation of your source data, knowledge data. The right side is the query part. So this is the live application part, querying. This is the preparation part, source on the left side. The same thing in the template you can relate to, right? Exactly the same thing. The top part and the bottom part. So is your data source, data pipeline, and the top part your query part. Isn't it amazing? Exactly the same architecture it has created as a template. Correct?
Yeah.
All right. So let's go to the data source creation part here. Now see, by default, it says AstraDB. We can always remove it and add it our own. But since it is native, today we are exploring AstraDB, so I'll just keep it that way. Now, go back and look at
When you see
this.
the icons, right? Why do we have that Chat GPT icons? I mean, just is it,
Where? This one?
yeah.
Because that is OpenAI, right?
Oh, okay.
Because this is AstraDB, you have DS here. Okay, so if you go and add Cassandra, see, you see the I here.
Oh, okay. It's native to the.
Yeah, whatever it is, whatever is the template you are selecting from here, that's what it shows, right? It shows FICE. It's the icon for the FICE DB. Okay? Is that what you're asking?
Yeah, right. Yeah.
Okay, that's fine.
I thought by default it will give the. I mean, Chat GPT
No.
icon. Yeah.
Okay. So sources, right? So we want in our RAG, we are doing from raw data sources, we are doing a file. So we have a file source here. Split text, we want to do chunking. So we had the split text, we are splitting it into chunks. Now you see here, we have the two parameters you can give. What is your chunk size? What is your overlap? Okay. And this is optional. We don't need to give what is the separator. You can use as is. Okay. So now this is connected from here. So if you go file, automatically connects to split text. So the split text, when you run, it will pull data from this widget, which is your file. If you have a file uploaded here, it will pull. If you don't have, it will fail, saying it does not have anything. It's like you are not passing any parameter when you're calling this function. It's empty, blank. Now, once you do chunking, right, you want to store into the database. Now, before storing the database, there are two options. One, we will let the database create its own embeddings, or we provide our own embeddings. We are choosing to provide our own embeddings, and then I am choosing to use OpenAI embedding model, text embedding ADA 002. So I can choose any model here. Again, why I'm able to choose is because I gave the OpenAI API key. Remember, here in the global variables, we set up the two keys. So one is the OpenAI API key that I got. I added it that here in the global variable. And because I have that key here, now I can select any model from the OpenAI. So again, see here, embeddings, they only have 3 models. So you can only see 3 models here. So one of this, I'm selecting ADA 002. Now what I did is, now I have chunkings. Chunking is done. It can read from the file, split it into chunks. And I have an embedding model which can generate embeddings. Now I have to connect these two. So when I'm writing to the AstraDB, here, what I am doing, I'm taking chunks. Okay, see here. So here, AstraDB, again, I have to give the AstraDB application token. Where did we get this token from?
That's the one that we generated.
Yeah, when we generated the DB, this cohort 5 DB, we have generated a token here, database token when you created the database. So you can have application token, you have a database token. So that database token we have stored here. This is the database token we are using. So that token is what I have stored here in the variable AstraDB application token. So it can go and select the database. Now, for this, there is a parameter which can take embedding model. So you take your embedding and then connect to embedding model. Ingest data. The data you are going to ingest into it is coming from this chunks from the split text. So it takes the chunks from in the ingest data from the split text. It takes the chunk and it uses this embedding model, embeds it and writes it to this database. So I go here and I will select. Okay. So see here, I'm not able to see the cohort 5 DB here. I'm only able to see resume DB because my global variable I am using is the old one, that key that I generated for resume DB. Okay. So I have to go and change the application key. Okay. So right now, if we go here, right now, if I want to select a database, I am only seeing resume DB here. Okay. Now what I have to go, I have to select cohort 5 DB. So I will go here, global variables, AstraDB application token. I can give a value and update it. So let's say we are going to use this token, new token, cohort 5, update variable. Okay. Now we will go back. Now change the name. Changed. Cohort 5. I don't know. Okay. Sometimes it behaves like this. Let's see here. Now let's go and see. See now I can see cohort 5, right? Earlier I saw only resume DB because I was using the old key for that database. Now I have using this database. So I'm using this. Another thing is you can actually go and use application token here. So if you use this token, it will show all the databases in your application because you are an admin. This is at the higher level. This is that each database, if you want, you can create a database key. You can only see that database. So now I'm using the database key. So I can see this only cohort 5 database. And then what are the collections in this database? To create a collection in this. Okay. So in cohort 5, there are no collections. I can choose to create a collection here, or since it is integrated, I can create from here as well. Say new collection, just say cohort 5 resume. Select an embedding generation. Remember, I am bringing my own. I'm using OpenAI, right? Then I have to give the dimensions. I know ADA 002, right? That is what I'm using the embedding model. It will generate 1536 dimension. So I use the same dimension here to create. So I'm directly creating from LangFlow because they are natively connected. So I can connect from AstraDB or I can create from here as well. So let's see. To take some time. Yeah. So cohort 5 resume is created. I can use that. That's it. We are done. Okay. Now we are ready to test our data source, the left part, right? So this part is done. We created file source, we create chunking, we created embedding model, we connected to the vector database, the collection. Now, if I run this with data, it should go and create that. I don't know if assume that is already created or it still takes time, but let's go and see. So what I said, and wherever you want to, there is this button, little button, you can go and run this. When you run this, it will run all the dependencies in the pipeline, whatever you are doing. So if you run only split text, it will run only this part. But if you run this, it will go and trace the lineage and start running all the dependent sources, dependent all components in the pipeline. It will run the entire pipeline. So first I have to upload a file, right? So the same file I will use the resume here, open. So that is the file. Now I want to upload this file to my vector database. So I'll just run this component. So you see it's running all of these, running here, built successfully. We can go to AstraDB here, refresh. See now cohort 5 resume is created here, 1536 dimensions. There are already 42 records here. See all the records have come in because we ran the pipeline. Good. First part is done, this part.
Yes.
Okay, so data is ready. Now we can go and query the data. So when we want to query the data, we go to this pipeline here. Okay. Okay. Do this. Okay. So retriever flow, we have a chat input again. So what do we need? We can just follow this. What components do we need? We need a chat input because this is where we put our query. Then we need an embedding model to generate embeddings from our query for comparison, retriever, right? So exactly, it has built a embedding model here. So remember, we have to have the same model here, what we used here in the source, right? Do you remember this rule? Oh, we used 3 small. Okay, yeah, so we can just leave it. Text embedding 3 small, that's what we used. OpenAI API key. We have used the same key. Now we are going to AstraDB application. Where is our database? Cohort 5 database. What is your collection? Cohort 5 resume collection that I'm querying. So embeddings, I connected to embedding model here. The chat query, I have connected to the search query here. See, I'm not connecting to ingest data. Remember, ingest data is for this part. When we are doing the source, building the source, we are connecting the chunks to ingest data here. But when we are querying, okay, when we are querying this, we are connecting this to search query and embedding model. So once that is searched, we get a data frame, results, we get chunks, of results from vector database. So we do a parsing of that data frame as a parsed text and then put it in a prompt template. So prompt is just like, context we are sending. In the context, we are just sending the parsed text. So this is important here. You have to see what are the variables you are sending in the prompt. What do we send in the prompt to LLM? What are the various components we send?
We send system info, then AI, and then there's one more, three pieces of it.
Yeah, from here, what are we sending here to LLM?
Okay, so you're sending the user query embedded one, then the
No,
information from
we are not sending the user query embedded one. We are
oh,
sending
you're sending the actual query, sorry. Actual query,
yes.
then the
Yes.
actual data that is from the vector database.
Yes, so we are sending the relevant data from the vector database, and we are sending the actual user query. So if you look at here very carefully, the context, that is your results, vector database results that are coming in from here, right? So this vector database results is going here, and that is what is sent as a context, right? This one. Okay. Now again, the user question. See here, this is the user question directly coming from the user chat input. Right? Can you see this?
Okay.
So the user input, one we are sending to generate embeddings and get the query here with the embeddings and the user query to generate results. The same user query we are also sending to the prompt, to the LLM. It's just like this. So the user query, one way it goes to embedding and vector database, one way it goes to the LLM. The same thing is generated in the template here. One copy goes to embedding and retrieving results from vector database. One copy directly goes to the prompt. And the retrieved results from here also come here. So now the prompt has both the retrieved results and the query from the user to pass it on to the LLM. So LLM receives it as input. If you want any system message, you can put system message here. Again, OpenAI API key. You want any model, 4O mini, whatever model you want, you can use any LLM model here, and then you get the output. So that is your complete pipeline. Okay. Questions?
Is it possible, to see the results from other models, by including them in the same window, or it has to be separate?
No, you can. It's all.
So if I want to see the output from other
whatever you
models,
want.
right? Okay.
So you just here, I will go and ask same question. What is the factor? Oh no. So this is okay. This is just the model, right? So RAG, we are doing RAG. So we want to ask questions about the resume, right? What are the certifications? So this is the playground to test your flow, the RAG workflow. See, you got everything formatted from the resume, right? Ask. You want to change the model? You can change the model, as I said here. So instead of 4O mini, let's say I want to use 3.5 turbo. Okay. I changed it to 3.5 turbo. You can just change the model just like that. Santosh was having this question some time back. Can we change models? Remember, Santosh? You pinged me offline. It's the projects in 10 lines. Okay. See, now the model is changed from 4.0 mini to 3.5 turbo. This is the summary of all the projects. Okay. Now the same thing, as I said, you can change this completely, remove OpenAI, put any other models. If you have that key, you can use Anthropic. If you have that API key, put it here, connect to it, you should get the same. You should be able to get the answer as well. Okay, so that is how you build your visually workflows. Basically, IDE, UI based, drag and drop all of your components, just like what we built using all of that code, can simply be created here visually. I know there is a little bit lag generating answers and all of that, but that is something to look at scaling and all of that using this. Yes, Anand.
Okay, since LangFlow is open source, what are the other ways to access that one? Here, always we are going through AstraDB. Is the only way, or without AstraDB, how can I access LangFlow?
Yeah, this is LangFlow, right? Without AstraDB or LangFlow, both are same. It's just two products in the same. See here, you can go from LangFlow to AstraDB or from AstraDB to LangFlow. But the URL, it always says astra.datastats/LangFlow. But both products are under the same thing, like under datastats. You can switch between both the products. That's what I'm saying.
Okay.
You can just go to langflow.com. It will again take you to the same URL, and then you can switch between these two products.
Okay, got it.
Yeah. And you can also access this. See here, if you go like switch, you can switch between these two. Okay. If you go Cloud 5 RAG and then say publish, this will give you a access from outside LangFlow. You are testing in the playground, right? Suppose, how do I test it from outside, not from within the here? Okay, I created a flow, I created a pipeline, I created playground, I checked it. Fine, then what? Text. How do I access it from outside my application? So I have some website where I created a chat bot, the window there from for employees. They type questions there. They cannot come to LangFlow and ask questions, right? So how do I answer them? So you can publish this, just like deploying to an endpoint. Okay, you get a token again. So this is your application token. Okay, take this, copy application token here. Okay, so this is your API token. It's called API token. Now, let's say I want to do with Python here. Frustrating. Copy this code. Okay, this is the Python code. Go to your Google Colab, our favorite file, just a new notebook, or you can go to Postman also. Okay, it doesn't matter. Unstable, is that what's happening? Okay. Gemini. Go here, paste. So it gave me the template code. So URL, it automatically gave the URL for that particular cohort 5 flow. See, all you have to do is replace your application token here. That is the API token we have generated, right? So take this token, come here and put it here. Okay, so this is the token. Now I can access that flow directly from here. So the question is, what is the document is about? Okay. Let's see. Let's keep it. And do we need anything else? I don't know. We don't need anything else. Just run this. Ooh, it's so slow. Gateway timeout. Anyways, so I think it is servers are responding a little slow, but this is the way to do it. Okay, so once you have published it, deployed it on endpoint, you get the token, you can use it as an API from anywhere to invoke that flow to get the answers.
So logging and all, if I want, I have to set a separate service in this Dragon type. As say the pipeline is failing somewhere, how to where to look at, how to look at, and how
Yeah,
to
all
fix
of
it.
that is your regular standard troubleshoot. So error handling, monitoring, tracing. So all of that you have to build. You're invoking just this workflow from the external system.
No, I'm talking about LangChain ETL, and then drag and drop.
Oh,
I'm
this
building
one?
my application there. Yeah.
Yeah. So when you run this, it will tell you which widget is failing, why it is failing. So that is all automatically written in the code itself, the handling part. See here, it raises the errors, whatever error. It has some error handling built in. If you want to add more error handling, you can add it here. This is the place, if you want to add when you are chunking, let's say you found some special characters or you want to fail or you want to skip anything here on failure, you can add any of your error handling or tracing here. That's why I said low code, you can drag and drop, but then if you want, you can edit and add your own code here. Character tests, filters, all of this. Okay. All right. So that's about the no-code platform. So tomorrow we'll be exploring most likely the Bedrock, AWS, Amazon Bedrock, same thing, similar, but not as detailed as this. We'll just touch upon, what are the components, because there's a lot of setup that is needed. You have to build the policies, IAM policies, and roles that are needed to create a knowledge base and everything, but still the same thing in a different UI kind of a thing. So I would say this will give you the most satisfying experience of building the flow, because all the components you have seen here, it's very neatly laid out and easy to hand, and templates and all of that, than Bedrock, I would say. But we'll still go explore, look at it, how Bedrock implements the same use case. And it is also expensive, it's not free. So just for one session tomorrow, it will cost me around $50 or so. But we'll go and do that. We'll try to do that use case, and then we'll see how it goes. And one more thing I wanted to talk about is we might have a vibe coding session sometime next week, where we will take a use case and use any of the LLMs to do a vibe coding, try to create the use case with the LLM generated code. Working on that, so most likely we might have that session next week, one of the sessions. Then we will move on to the agentic part. Okay, whoever is excited, want to do hands-on, can join, will join. I mean, even though, so you can also join if you don't want, but I would rather prefer, you also do like hands-on when I'm doing, start generating and looking at the code and implementing and all of that. It might have some components which you are not seeing, like I'm not still sure, maybe we may use Snowflake account. That's also a trial account you will get for 30 days. Maybe we can use that to do some ETL, generate some code and run on Snowflake, like stored procedures or something like that, or the Snowpark scripts. It might be a little overwhelming, but at least we will be able to see how in a real world scenario we use AI to help us improve the productivity, at least in coding sessions. So that's what we're going to explore next week. And then we will get into the agentic AI. So tomorrow, AWS, Bedrock, and then later we'll go next week. The second half training will go into vibe coding and agentic and all that. Okay, excited?
Yes. Ron,
Awesome.
thank you.
Thank you so much, guys. Appreciate your time. Take care. We'll put the recordings and the, I think that we don't have any other artifacts. So just the recording as soon as possible. Awesome. Thank you so much.
Thank you.
Take
Bye-bye.
care. Have a good day.
Thank you all.
Bye.
Have a good day. See you.
Okay.